So it's Smokey Bear Jr. And our sponsor was North Carolina Forest Service Group. My name is Zach Helvey. My teammates are Amir, Austin, Matt, Justin, and Ashton. And so my role here in the project was I was in charge of the software piece of it, along with helping with the design of the PCB. And then Austin was in charge of hardware for the PLC. Amir was in charge of the power calculations for the power system. Matt was in charge of helping structurally and help stitch together the bear. Ashton was our mechanical consultant, and Justin helped with the remote control system and assist other people where they needed it. So our project solves the problem of that they currently have a 22-foot bear that they bring out to state fairs and things like that. It's pneumatically controlled, meaning that it uses air pressure to move the different motors and things like that. But the issue is that it gets condensation in the lines, so we redesigned the system electromechanically to eliminate that problem altogether. So our process really was that we wanted to model the other bear. It needed to have the same range of motion and look aesthetically about the same. So our process was really just to mimic that and then redesign the control system, which obviously was electromechanical. Pretty much how he moves is he has some motors built in right here. He has some different actuators and things like that. We have the control system in the base, which runs the wires up to the top. And so we programmed it to use position feedback. And so what that basically does is it allows the CPU to know where the bear is at a specific point. And that way he runs through the different motions and he has a set range of bits, positions that he knows he's supposed to run through. And then when he gets there, the motor's cut off through the system with relays and then starts back up when it needs to move back up. I think what we learned the most from the project is how key coordination is when working on something like this. You have all these different subsystems that you're working on together for a long time, and then you have to integrate them all together. So it's really key to communicate what everybody's doing, making sure everybody's on top of their stuff. That way there's no issues that arise later on, and everything flows well together. So the features are, and anybody's welcome to use this remote control, so we have this remote control, and it has an auto and manual function. So it's an auto function. It runs through all four motions: the arm, the head rotate, the head nod, and the mouth movement, all in sequential order. And then you can also have a manual mode here. But before it goes to that, we have a fail-safe so that you can't run auto and manual at the same time. So it's going to complete the auto functionality. And then when you go to manual, you have these different buttons you can press. So you have the mouth movement, you can move on its own. And notice when I'm running one motion, I can't push a button to run another. And that's on purpose because that's how they currently have the bear, and they don't want it to change. And then we also have a reset button. So if it loses power during the middle of a range of motion, or if some kid hangs on a particular ligament and pulls the motor out of place, then you can go inside the box actually and press a reset button that will bring everything back to its original position.